Okay, we're going to have a go at finding the fourth roots of a complex number, 2 plus 2 root 3i, and we'll use de Moivre's theorem to do that. Now, another way of expressing this question is we could say solve for z, following equation. Z to the fourth is equal to 2 plus 2 root 3i. Okay, so just two different ways of expressing the same thing, finding the fourth roots of this complex number or solving this complex equation here. First thing we're going to do is locate this complex number on our Argand diagram. You notice that the real part 2 is 2 and the imaginary part is 2 root 3, and the imaginary part has got a greater magnitude, so the complex number is going to be up there somewhere. Locating that. We have our real part of 2 and our imaginary part of 2 root 3. We've got some angle theta here as well. Okay, so in terms of where we want to go from here is to use de Moivre's theorem. We want this complex number, which is currently in rectangular form, we want it in polar form. So we're going to change the rectangular form to polar form to start with. And first of all, we call that z to start with. Magnitude of z here will be equal to square root of 2 squared plus 2 root 3 squared. So that gives us the square root of 4. And for here we've got 2 squared is 4. Square root of 3 is just 3, so we end up with 4 times 3. 4 plus 12, square root of 16, and we get z is equal to 4. And also we know that tan theta, tan of this angle here is opposite over adjacent, which is 2 root 3 over 2, 2's cancel, and we end up here with one of our exact trig values here, tan theta equals root 3, so we can say that theta is equal to pi on 3, or if you're working in degrees, that'd be 60 degrees. Okay, so now what we can do is go back to our equation that we're trying to solve for z, and put in the equivalent polar form of the complex number, which will be magnitude is 4, cis, and then our angle is pi on 3. Now at this stage here, what we know about solving this equation is that we're looking for fourth roots, which means we're expecting 4 solutions here. And in this case here, to deal with that, what we can say is that for this complex number, it has an angle of theta, but another possible angle is the angle where it rotates all the way around a further 2 pi or 360 degrees. And then, of course, we go around another 2 pi, etc. So what we could say for this polar form of the complex number is we could add on some multiple of 2 pi. So as our angle, it could be pi on 3 plus some multiple of 2 pi. Okay, so now that we've got that, we can go ahead and solve this equation. To do that, we're going to take fourth roots of both sides. So we'll get z is equal to 4 cis pi on 3 plus 2k pi to the power of 1/4. And of course, that 1/4 will be a whole expression to the power of 1/4. There we go. So now that we've got a complex number in polar form raised to a power, we can use de Moivre's theorem to deal with that. And we end up here with z is equal to 4. Now remembering with de Moivre's theorem, when we raise to a power, the magnitude gets raised to that power, so we get 4 to the power of 1/4. And then the angle gets multiplied by that power. So what we have here is pi on 3 times 1/4. So that will be pi on 12 plus 2k pi over 4. Okay, so from there, let's go ahead and work this out. Now we've got a bit of work to do with our 4 to the quarter. We can think of that as 4 to the half raised to the power of a half. And then here, we'll just leave that as cis pi on 12 plus, let's simplify the 2 and the 4 there, we'll get k pi on 2. So now we can see that z, we've got 4 to the half, which is really just the square root of 4, which is 2. So we've got 2 to the half cis pi on 12 plus k pi on 2. Now at this point here, we now bring in the different multiples of k here. And we'll start off with k is equal to 0. So when k is equal to 0, we've got, let's call that z1 for our first solution. 2 to the half is really just square root of 2. So we've got root 2 cis. And when k is equal to 0, this term becomes 0. So cis pi on 12 is our first solution. z2, we'll have root 2. This time we're going to use k is equal to 1. So we'll have cis pi on 12 plus pi on 2. Now pi on 2 is the same as 6 pi on 12. So we can write that as, oops, let's just move it up a little bit. There we go. So we can write the pi on 12 plus pi on 2 as root 2 cis. So pi on 12 plus 6 pi on 12 gives us 7 pi on 12 as our second solution. My third solution, I'm actually going to use -1 here, just because we're going to, quite often we go from negative pi through to pi for our range of angles. So I'm going to use -1. So that was k is equal to 1. This one's going to be k is equal to -1. So using a -1 in here, we're going to take away negative pi on 2. That'll give us root 2 cis pi on 12, take pi on 2, and that equals root 2 cis, so it'll be pi on 12, take 6 pi on 12, so that'll be -5 pi on 12. And then finally, for when k is equal to -2, we'll get our final solution. Z4 is equal to root 2 cis, this time it'll be pi on 12, take away, so this time it'll be 2k, take away 2 pi on 2, so take away 2 pi on 2, and that gives us root 2 cis, -11 pi on 12. Now you can see that final solution there does fall within the negative pi to positive pi range that we often use for our angles. So there's our 4 solutions. We've got root 2 cis pi on 12, root 2 cis 7 pi on 12, root 2 cis -5 pi on 12, and root 2 cis -11 pi on 12. Okay. The final point you'll note with these 4 solutions here, in particular the angles that we have, is that the 4 solutions, if we take our initial solution, the other 4 solutions divide the Argand plane into 4 equal angles. So we've got our first solution here, which was root 2 cis pi on 12, which is sort of out here somewhere. There's Z1. Z2 is up over here. Z3 is over, whoops, we have Z3 down here. And Z4 was over here. And what you'll notice is that because it is a 4th root, the Argand plane with our 4 solutions gets divided into 4 equal angles. And because 2 pi divides into 4 pi on 2, each of the complex numbers is spaced at pi on 2 or 90 degrees. And that's the other way of coming up with the other 3 solutions. Once you've found this solution, you can just divide the Argand plane into 4 separate angles to get your other solutions if you like. Okay, and that's it.